This lecture is going to address the concept of significant figures, and we'll also be looking at some principles of measurement as well, because the two are related. Here are the key concepts that we'll be discussing in this particular lesson. We'll be looking at explaining how you would take a proper measurement and which figures are significant when you do take a measurement. So we'll actually do a little bit of practice taking measurements within this lesson. Second, there's a set of rules for significant figures. We'll be applying those rules to a given measurement. So this is not so much about taking the measurement, it's once the measurement is given, how do you analyze or determine how many significant figures you have in that measurement. And the reason you need to do that is really key concept number 3 here, which is using those significant figures in basic calculations. And that's really our end result. In chemistry, we're looking to do a lot of calculations based on measurements that we take, and so we need to know some rules that govern that. And so here is a significant figure, some of the basics, and the reason we have things such as significant figures is because each measurement has some uncertainty, and so we need to know which numbers are actually meaningful and how do we determine that. Sometimes your calculator might spit out 10 different digits. That doesn't mean they all matter. That doesn't mean they're all significant based on whatever you're using to measure. So as a definition here, a significant figure is any digit that is reasonably certain. Okay, that doesn't mean 100% certain. There's some amount of doubt, and so a significant figure is what you're reasonably certain about. So here's a bar. This is just any length, and we're going to measure it here with a ruler that's going to come up, and it's a little bit blurry, but hopefully it's clear enough to see. So here is your ruler. It's measuring in millimeters. Now actually what that means here is each of these individual little tick marks is a millimeter. These big numbers here are centimeters because there are 10 centimeters or 10 millimeters in 1 centimeter. So let's say we're going to measure it in centimeters. So how would you go about measuring this? You might look at that and you'd say, okay, well it's clearly more than 4, it's not 5. This is 4.5, so maybe you would say 4.2. But how certain are you that that 2 is the end of the line? Is it between 2 and 3 at all? Is it right on that 2? If you think it's right on this second tick mark here, so 4.2, if you're saying it's absolutely there, you're saying it's 4.20. And so that 0 is actually your guess. If you think it's a little bit past and maybe 4.21, that'd be kind of the guess. You're sure it's at 2, but then after that, that's where your uncertainty is. So when you take a measurement, you always want to have that one digit of a guess. And so we'll look at that in a little bit more detail here. So when you do take a measurement, the proper way to do it is every single digit that you know for sure. So in that last one, we knew it was more than 4, we knew it was 0.2, and then that last one was our guess. That's this one digit, and you only get one digit of guess. It wouldn't make sense to say 4.21, that 1 is the guess, but I'll say 1.5, because you're guessing after a guess, and that is not considered significant. So we'll look at another example. This is measuring water in a graduated cylinder, and here's a little bit of technique for you. This curve here is called the meniscus, and what you want to do is measure the bottom of the meniscus. Okay, so that is your measurement here. So here's 6, here's 8, so it looks like this in the middle here is 7. Okay, so then you got to figure out how much each of these is worth. So 2, 4, 6, 8. Okay, so it looks like each of these is worth about 0.2. So you know it's more than 6. It's not 7. So 6.2, 6.4, 6.6. Okay? You're pretty sure on the 6. You need to make one more digit of guess. So I'm going to say that's on the line, and I'm going to say 6.60. But in this case, that 0 is my guess. This is considered a proper measurement. 6.6 is not enough. Obviously, if you were to just say 6, you can do better than that. We're trying to get the most precise measurement we can, or we want to get something that is as close to the number as possible. So we're looking for precision and accuracy. So you want to have that one digit of guess. So that's a quick introduction to how you would take a measurement. And it's all based on what instrument you have and making that one digit of guess. Now we're going to move on to a situation where you're given a number. So let's say you've already taken the measurement and you're trying to figure out which are the significant figures. And really where this comes into play is what to do with zeros. Zeros can be a little bit challenging when you count them, when you don't, and it's not always so clear-cut. So here are those rules. There's about 6 of them. So as a first example for rule number 1, if you take that number 4.564, that has how many significant figures? Well, if that's a reported measurement and you know, so this 4 here is your guess, you count all of them. Okay, so this particular measurement would have 4 significant figures. So here's your rule. Every non-zero digit in a reported measurement is considered significant. So this is your reported measurement. Those are all considered significant. Here's one more example. 5.62 has blank significant figures. Go ahead and take a guess at that. If you need to pause the video for a moment and at any time to do these practice problems, go ahead and do that. 5.62 has 3 significant figures, right? Those are all non-zeros, pretty straightforward, so you count them all. Okay, first one's the easiest. Rule number 2. 4.056 has blank significant figures. Okay, so we've got a 0 in there. So what do we do with that 0? Well, in this particular case, this measurement also has 4 significant figures. 1, 2, 2, 3, 4. So these are all significant. So here's the rule that we derive from that. Zeros that are between non-zero digits are considered significant. So you've got that 0 between the 4 and the 5. So that makes it significant because that means this isn't a guess. The 6 is the guess. This is certain, so you would count it. Here's another example. 5.0725 has blank significant figures. Take a guess at that, and also consider which of those digits is called the, well, guess. Which one is the last digit of certainty? And it would be 5 total significant figures, and this number 5 here that I'm circling, that's the guess. That's the final digit. So because that's the guess, everything else is considered before it. Everything before it is considered significant. Moving on, rule number 3. These next 2 are a little bit more challenging. Alright, so we have a small number here. 0.000435 has blank significant figures. In this case, it has 3. You might have guessed 6, but in this case, it's 3. And here's the rule on that. Leftmost zeros, so that means leftmost, they're on the left side of the number, that are in front of non-zero numbers, they're not considered significant. And the reason for that is they're kind of just placeholders for a factor of 10. They can be gotten rid of with some scientific notation, right, if we just move the decimal place over. So they would almost disappear in a way. They're not considered significant. Here's another example. Pause the video if you need to. 0.0021. 3 significant figures. Excuse me, that's incorrect. 2 significant figures. That is not right. This should be 2. Okay, very good. Hopefully you got that right because it looks like I got it wrong. Okay, next. Rule number 4. Different rule here. 5.0540 has blank significant figures. Well, here's what we can figure out. Remember which is our guess in this case. It's the last number. So this is our guess. It's still considered significant. So this has 5 sig figs. 1, 2, 3, 4, 5. So all of these are considered significant. This is the guess. If this was a 1, you would count it. So it's just a 0. It happens to be a 0. That's it. So 5 significant figures. Here's the rule. Zeros at the end of a number that are to the right of the decimal place, so this is the decimal, it's right of the decimal, those are considered significant. You count those. Okay, here's an example for you. 9.210500. How many significant figures? Pause the video if you need to. Write it down, take a guess. And it is 7 significant figures. 1, 2, 3, 4, 5, 6, 7. All of them count. And the reason all of them count, again, is because this is your guess. And if this is the guess, that means all of these are certain measurements. These are what you know. So you count them all. Moving on. Rule number 5. Okay, here's a number. How many significant figures would that have? In fact, this has 3 significant figures. This is kind of similar to rule number 3 in that these zeros can be dealt with scientific notation. So, zeros at the end of a measurement that are to the left of the decimal, so we would have a decimal place here, are not significant. So these 2 here are not significant. So in this measurement, it's 1, 2, 3. These are all considered significant figures. These 2 zeros at the end are not. Here's another example. Here's an exception coming up. And this is maybe a little bit annoying, but if a decimal place is included after the zeros, so see how there's nothing here? If there actually was a decimal point there, it makes the zeros significant. So notice the difference here. 649000 with a decimal place. This has 6 significant figures. This decimal place makes the zero significant. Up here, no decimal place, so only these are significant. Kind of annoying, I know, but it's just one of those little details. This decimal point is one way to say I measured these zeros and they matter. In this case, no decimal point, it means I only measured up to this 4. So that's my guess. In this measurement, this is the guess. And the final rule coming up. And we're going to use this one actually a fair amount this year, this rule. So this rule, there are 47 students in this class. How many significant figures are there? Well, assuming that I can count properly, there's no uncertainty in that measurement. I'm not sure if there's a half a person somewhere out there, or maybe it's plus or minus 1. If it's certain and you can count it, there is no uncertainty. Sometimes that's the case. So if you're given a value or an exact quantity. So in this case, this is an exact quantity. A given value is like there's 10 millimeters in 1 centimeter. That's given. It's known. There's no uncertainty. That's called an infinite number of sig figs. And that infinite is important for what we're going to get into next, which is the math part of significant figures. And what that's just going to mean is that you're not going to pay attention to, say, there's 2 significant figures here. This is an infinite number of significant figures, and we'll go through an example. So those are the rules, all 6 of them. It's going to seem like a lot at first, but you'll be able to get more into it. You'll get more practice with it the more we do this throughout the year.